Thank you so much for joining me for Science Stories. My name is Mrs. C. Today, I'll be reading a book titled How Mountains Are Made. Our author is Kathleen Widener Zofield, and our illustrator is James Graham Hale. So he drew these beautiful pictures, and she wrote all of the words in today's book. Before I begin reading, let's look at some of the vocabulary words that might be a little tricky or you might not be sure about. How mountains are made. Here are 6 vocabulary words that we're going to review before I read. The first word is valley. Next, we have steep, plain, craggy, pressure, and last we have friction. Here are some pictures that will help us understand each word and its definition a bit better. Our first word is valley. A valley is a low area of land between hills or mountains. So right here you can see there are some very tall mountains going up on each side. There are some in the background too. This area in the middle, this one has a river in it, which is pretty cool, is the valley. Up here on my little image, you can also see in between these two mountains, this area would be called the valley. It's a lower area between the hills and mountains. Our next word is steep. Steep means rising or falling sharply, nearly perpendicular. Perpendicular means straight up and down. So look at this mountain climber. The mountain that they are climbing is very steep. It's going straight up into the air, right? It's very steep. Sometimes you might even hear these parts of mountains called cliffs, right? A cliff is very steep. Our next word is plain. This type of plain is a noun, so it's a thing. It means a large area of flat land with few trees. You can see in this picture there are no trees, but a plain can have some trees sometimes, just not very many. So this is a plain. It's kind of like the opposite of a mountain, right? Very flat, it's not very steep at all. Our next word is craggy. Sounds kind of like crabby, right? Like when you wake up in a bad mood, but this is craggy instead. Craggy means a rough or uneven cliff or rock face. So it's very, very sharp. Look at all these parts that are jutting out and going up and down, right? It's very rough. It's not smooth at all. If you were trying to climb this, it'd probably be very difficult. You might fall because it is very craggy. Our next word is pressure. Pressure means a continuous physical force exerted on or against an object. So let's look at these images to help us understand that definition. Right here, I can see this area of land is moving in this direction. This area of land is moving against it. So they are pushing against each other constantly or continuously. They're pushing against each other. And look, right here, it's forcing some mountains to actually push up from all of that pressure, right, to get taller. Right here, we've got magma building up in this magma chamber. Magma is lava, right, before it touches or comes out of the Earth's crust. So this magma is building pressure, right? That's a force. And when it gets too filled and too strong in here, boom, that force can cause that magma to be exerted or to be expelled out of the volcano as lava, right? So that's because of all the pressure or force. And our last word is friction. You can even practice this at home. Friction is the action of one surface or object rubbing against another, and sometimes it can cause heat, right? So right here, the friction between these pieces of wood can actually get so warm that it causes a fire to start, right? This is how you can start a campfire sometimes. Up here, you can see these hands rubbing together. If you rub your hands together really quickly, back and forth, you will actually start to feel your hands get warmer. Maybe you do this when it's cold outside sometimes. That's because of the friction rubbing against. All right, so those are all words that you're going to hear today while I'm reading. And now hopefully you'll understand how they work in our book a little bit better. Let's look at our front cover again. Here's our title, How Mountains Are Made. Here's our author and our illustrator. And here's our back cover. Our back cover tells a little bit about this book, and it also shows you some other science books you might be interested in as well. All right, let's begin reading our story. On Saturdays, sometimes we go mountain climbing. We follow a trail through a thick forest. At first, the climb is easy. We live in a little town in a valley. There are mountains all around us. Then it gets steeper and steeper. See how steep that mountain or that cliff is? We stop on a rock ledge halfway up and eat our lunch. Are we there yet? When we start out again, we have to walk more slowly. The slope is getting very steep. The forest is thinning out and the trees are shorter. We can see the top of the mountain, but it seems to take forever to get there. When we reach the top, we can see out in every direction. There are hardly any trees up here, and the land is rocky. We spend a long time looking at the rocks. Here's one with the shape of a seashell in it. See that illustration? It's a fossil. Cool. Fossils are the remains of animals that lived millions of years ago. This mountain is more than 4,000 feet high. That's nearly a mile. There are no oceans up here. How did a sea animal get to the top of this mountain? The highest mountain in the world is Mount Everest in Nepal. It is 29,028 feet high. That's almost 5.5 miles. But fossil seashells have been found on Mount Everest too. Mount Everest would be about this high compared with our mountain. So the mountain in the story that the kids are climbing is not very tall. Here's sea level right here. Our mountain is less than 1 mile above sea level, so it's way down here. Mount Everest is way up here. The deep sea plains are between 2 and 3 miles below sea level. So the mountains are above sea level and the sea plains are below. Millions of years ago, Mount Everest was not a mountain at all. It was a flat plain under an ocean. Our mountain was a flat plain under an ocean too. All sorts of sea animals lived right here, but that was a long, long time ago. Many changes have happened since then. The earth is always changing. Old mountains disappear. They are worn away by wind and ice and rain. New mountains form where there were no mountains before. We can't see changes happening though. Mountains are built and worn down gradually, that means slowly, over hundreds of millions of years. So very slowly. When we look at the earth, all we see are rocks and soil, and the trees and other plants growing in the soil. But if we could look inside the earth, we would see that it is made up of different layers. The surface of the earth is the first layer. It is made of the soil and the rocks we see around us all the time. Just under the surface is a rocky layer, about 35 miles thick, called the Earth's crust. Beneath the crust is a layer of solid rock about 60 miles thick. The crust and this thick rock layer together form an outer shell called the lithosphere. The lithosphere is broken into pieces called plates. The plates are huge. There are 8 major plates and several smaller ones. So here's a map of the Earth, and you can see it's broken into different sections. Those are the plates. The United States, Canada, and Mexico are together on one of these plates. Europe and Asia make up another, and then you can see all of the other ones as well. There are several. Under the outer shell is a layer of hot, partly melted rock called magma. The rock plates float on top of the hot magma. The plates move slowly over the magma, just a few inches a year. The Earth's plates are always in motion. They have been moving for hundreds of millions of years. Most scientists believe that all the mountains on Earth were formed by slow movements in the Earth's outer shell. But mountains in different parts of the world look very different from one another. There are folded mountains, dome mountains, fault block mountains, and volcanic mountains. Some have sharp pointy peaks, others are more rounded. Still others are block shaped, and a few are shaped like tall cones. That's because in different parts of the Earth, the outer shell moves in different ways. In some places, two plates press against each other. The tremendous pressure forces the crust to lift and fold over itself. Scrunch, scrunch, scrunch. These are folded mountains. Great waves of rock are pushed up, and sharp, craggy mountains are formed. If you have a heavy dish towel or hand towel, you can see how this folding happens. Lay a towel out flat on a table. Put the palms of your hands down, one on each end of the towel. Then slowly slide your hands toward each other. Scrunch! The folds and ridges that appear in the middle of the towel are like the folds and ridges that form giant mountains when two plates press against each other. In other places, pressure deep within the earth pulls and stretches the crust. The stretching sometimes causes long cracks or fault lines to cut through the crust. Crack! These are fault block mountains. The crust on one side of a crack may slide slowly upward, while the crust on the other side pushes downward. Block-shaped mountains are formed this way. Sometimes the crust does not fold or crack. Sometimes magma pushes through a vent in the solid rock layer. It collects in a pocket under the crust. The pocket of magma grows larger until it bends the crust upward. Dome mountains. When this happens, a high dome is formed. Rain and wind and ice wash away the softer rocks above, and rounded peaks and valleys appear. In a few places on Earth, plates are moving away from one another. This usually happens deep under the oceans. This is an image or a diagram of the underwater mountain range. Magma pushes up between the space between the plates. When it hits the cool ocean water, the magma becomes solid. Great underwater mountain ranges are built up. Once in a while, a small crack or vent forms in the lithosphere, sometimes right in the middle of a plate. Red hot magma pushes up through the crack. When it gets to the surface of the earth, the magma cools and hardens. Once magma reaches the surface, it's called lava. So you can see this is the magma, and then this is the lava. It's the same thing, it's just now it's outside of the crust. Lava and ash build up around the crack, making the land higher and higher. A cone-shaped volcanic mountain is formed. Most volcanic mountains are formed in places where one plate pushes under another. As the edge of one plate sinks, pressure and friction cause it to heat up. The solid rock of the plate's edge melts in the intense heat. The melted rock or magma rushes up through weak places in the crust above. Volcanic mountains. In fiery blasts, magma is thrown onto the Earth's surface. It cools and hardens, and mountains are built. Some mountains have been around for hundreds of millions of years. Others are still being built up right now. The mountain we climbed is an old mountain. The fossil we found can tell us a lot about how old our mountain is. Scientists have a special way of telling the age of a fossil. This one is nearly 280 million years old. That means this sea animal was actually swimming here 280 million years ago. It died, sank to the bottom, and was buried in sand and mud. It must have been buried sometime just before our mountain began to be born. So we know that the land here began to rise about 280 million years ago. From the shape of this mountain, we can tell it was formed by a folding of the crust. Two huge plates slowly pressed against each other. The land rose higher and the sea disappeared. Over millions of years, the crust folded up in tremendous waves. This mountain and the other mountains around our town were once much higher than they are now. They were sharp and craggy. Now they are lower and smoother. For millions of years, rain, wind, and ice have worn our mountains down. Millions of years from now, the rain, wind, and ice will have worn them down completely. there will be no mountains here. So this was millions of years ago. Look how sharp and craggy the mountains were. This is now, right? The wind and rain have washed them down and eroded away some of the cragginess, so now they're more rounded. And look, millions of years from now, they'll be washed away completely. Mount Everest is a younger mountain. It is still sharp and craggy, and it is still being pushed up higher. Mount Everest may be growing as much as 2 inches each year. So you can do that with your finger. That's about 2 inches, right? You can show that. We're not going to try to climb Mount Everest. This mountain was high enough for us. And look at the beautiful valley in between again. You can see the valley in between the mountains. Here is a map of the United States, and here are some of the mountain ranges that we have. We have the Appalachian Mountains. They're in North America. They're folded mountains. We also have the Hawaiian Islands, which were volcanic cones that pushed up from the ocean floor. We also have mountain ranges called the Alaska Range, the Olympics, the Cascades. They're over here on the West Coast, and it says they are among the youngest mountain ranges in the U.S., and they are still growing. You can also see the Brooks in Alaska, the Canadian Rockies, the American Rockies, and way down in Mexico, we have the Sierra Madre. It says they're all part of one long mountain range that was formed by a mixture of folding, faulting, and volcanic activity. So all sorts of different mountains in there. Really cool stuff. All right, I really hope you enjoyed our book and our story today and learning more about how mountains are made. I will see you next time. Thank you so much. Bye-bye.